Hello students, welcome back to chemistry online class brought to you by iGoTerra virtual learning platform. I'm Olabisi Olaweye, and I'll be teaching you chemistry. The first topic I'm going to take is the introduction to chemistry, and the topic that WAEC syllabus covers here are the physical quantities and their measurements, then the method of science or the scientific method. The topics have been carefully selected, and you're expected to cover the necessary aspects. I want to advise you to pay attention to details so that you can get the best. Now, at the end of this class, you're expected to be able to define or describe the SI units, differentiate between the fundamental quantities and the derived quantities. Then also discuss on the precision of measurements and be able to convert some values. So let's look at the first part here, which is the meaning of units. You might have come across different units when you are taking measurement of liquids or distance or the material. You want to know that carpenters they take measurement of the planks or wood they use in working. Scientists also take readings, in the laboratories whenever they are carrying out practicals. So also in our everyday life, we come across different readings. So it is very important as a science student and as a scientist to be able to know the correct unit to use. So unit here refers to the amount or magnitude of any physical portion that is measured. And when you understand the fundamentals and the introduction to dimensions of physical quantity, it will help you to know the correctness of a particular formula given to you, and the conversion of units as well. So we are going to be using using the SI unit to explain this. The SI here stands for System International, and it is actually the international system of units which has been acceptable worldwide. This was introduced because of the problem of using different units by different countries. So it was brought up, and it was widely accepted by all scientists. So under the SI unit, there are 5 major fundamental quantities, though 2 has been added to them. So what are these fundamental quantities, and what is the second part? How is it different from the derived quantity? The fundamental quantities are the basic units which other quantities or units are derived from or they rely on. Now, we have the first one here, which is the meter. The meter is used for measuring length. It is M. It is denoted as M for measuring length. That is the original unit, and is a fundamental unit. Another one is a kilogram for mass. That's the quantity of matter in a body. The length can be used as when we are measuring distance, materials, and so on and so forth. The kilogram can be used to measure mass, which is a quantity of matter in a body that is used to check maybe materials, food, items, even the body itself of human beings and other substances, even in the industries, using scales. While the length can use meter rule, tape rule, and so on. Even a ruler can be used as well. Now, the next one is the seconds, which is denoted as S for time, and the instrument we use here is the clock. Then we also have the Kelvin for temperature, which is measured using thermometer. The Kelvin is used to measure temperature, which is the degree of hotness or coldness of a body. Then we have the ampere for the electric current, which is the measure of the amount of current passing through a body. And ampere is denoted as A, and The next one is the mole, which are the last two. These last two are the new the new fundamental quantities. So the mole, which is MC, and is for the amount of substances. It's used to measure amount of substances, which is mole. Then the next one is a candela, that's CD, for luminous intensity. It's used to measure the intensity of light. Then we have the derived quantities, which are derived or gotten from the fundamental quantities. So the derived quantities are the physical quantities derived from these 7 fundamental physical quantities. Examples are, I'm going to be giving you some examples here. The area. Now you can remember, if you are measuring the area of a body, for instance, let's say the area of a square. The area of a square has equal side, length by length. The length here is in meter, while the other length is meter. So by the time you multiply length by length, you end up getting meter square. You can see the reason why area is meter square and is a derived quantity, because it was derived from the meter itself. Now the next one is the force, N, which is Newton, and this is also a derived quantity. Another one is a volume, which is a three-dimensional unit. Its length, for instance, if it is a cuboid, we have the if it's a rectangle, we have length times breadth times height, so which is meter cube. This accounts for the reason why we have the cube there. Combining different fundamental quantities together, we call them derived quantity. And there are some principles we need to understand, and the conversions of some some values. For instance, now we have the common SI prefixes. That's the kilo contains 1,000 gram. The mega, which is 1 kilo, contains 1,000 gram. The mega here contains 1 million gram. The decigram contains 10. With 10 decigram is equal to 1 gram. For 100 centigram is equal to 1 gram. For milli, 1,000 milligram is equal to 1 gram. Micro, 1 million microgram is 10 raised power 6 gram, which is equal to 1 gram. Nano is 10 raised power 9 nanogram is equivalent to 1 gram as well. That is a billion. Now, all these will help us to be able to convert units. For instance, now we can convert gram to kilogram. If you have 2 kilogram and you're expected to convert it to gram, we'll just multiply by 1,000. You get 2,000 gram. If you want to convert gram to kilogram, that's from small to big. Because kilogram is bigger than gram, you have to divide by 1,000, and so on and so forth. So that leads us to the precision of measurement. What do we understand by the precision of measurement? Every measurement adds some degree of uncertainty associated with them, and they depend on the precision of their measurement. For instance, now a bedroom scale is not as precise as an analytical scale. An analytical scale will take to details the tiny readings, the minute readings. Why the bedroom scale will only round up and give us just one number after the certain digit. So let's look at this example. A grapefruit, 2 grapefruits which are almost the same size were measured using the bedroom scale, and it gave the same mass for the two, 1.5, 1.5. Why the analytical scale, when it measured the 2 grapefruits, one measured 1.476 while the other one measured 1.518. You can see the degree of accuracy here, that this measures it shows the difference in the two, because the two cannot be exactly the same. So this take into details the real value. So we can say here that the higher the significant figures, the lesser the error, and the more precise the measurement. Let's look at the example of a ruler. Look at this ruler. This one now, it gives us, we can only run. Let's take these readings. Let's take the readings of this object at the center. Now we can see this can be approximately 2.5 by estimating our value, because we are sure of 1. 1 is certain, 2 is certain, but this value at the middle is not certain, so it is assumed to be 5. So we have 2.5. So in this case now we have two significant figures. Now if you are to take the reason, you can see this is calibrated. Now after these two, 1, 2, we are sure of them. We can still be sure of these ones that will count until we get to 0.5, 0.6. In between 0.5 and 6 is the line. So this is really taking into details the precise reading. So we can end up getting 2.55 centimeter, which is 3 significant figures. So the first value here is a certain digit. This is also a certain digit, while the decimal fraction is an uncertain digit. So it's just like the best guess. So in this case now we have 3 significant figures and we have 2 significant figures here. So the second measurement is actually the precise one, if I may ask. If you are asked now which one is more precise, this is also applicable in taking readings in our pipette during titration. It is very important to take into take note of the readings. You don't round up, because your answers are expected to be expected to be in concordance. That's a difference of 0.2 plus or minus. So you should not round up your values, because the values will also be used to work out some questions. So when taking readings, especially in titration and in other practical or experiment, always take note of the actual value without rounding up. So the second readings is more certain. There is a least amount of uncertainty associated with it, because it takes into reading the precise value. So the greater what is now the importance of significant figure in taking readings? The greater the amount of significant figures, in this case now we have 3, the lesser the amount of uncertainty and the more precise your values. So in this case now, the significant figure represents the number of certain digits and one uncertain digit. So the higher the greater the significant figures, the more precise your value. That's what I'm trying to say here. And here I would like to ask you some questions, and I want you to practice them. I'm going to stop. You solve the questions, then we come back. Express 5 gram per 500 cm cube in gram per dm cube. Then convert 1 hour 20 minutes to seconds. So welcome back. Let's quickly solve the question. Express 5 gram per 500 gram in cm cube in gram per dm cube. Now, what they are trying to say is what if 5 gram is in 500 cm cube? How many gram will be in 1 dm cube? And take note that 1 dm cube contains 1000 cm cube. That's centimeter cube. That is inside one decimeter cube, there is 1000 centimeter cube. So if you have 500 centimeter cube, how many times do you get it in 1 decimeter cube? That is like 2 times. So if 5 gram is in 500, 2 times 5 will be 10, will be in 1 dm cube. So the answer is 10 gram. But for better understanding, we can do it this way, that if 5 gram is in 500 cm cube, x gram is in 1000 cm cube, then we cross multiply. So x multiplied by 500 equals to 5 multiplied by 1000. Dividing both sides by 500, we have our answer as 10 gram. The next question. The reason why I gave you this question is because we use it in titration. You may not be given your values directly as per dm cube, maybe in per cm cube, which you have to convert to dm cube. In this unit is for mass concentration. That's concentration of mass per dm cube. Now another one is converting 1 hour 20 minutes to seconds. Students usually find it complex to do. This question is, I think the reason why I gave you this question is in calculation of the quantity of electricity, Q. In Faraday's, the formula is Q equals to IT. T here must be in seconds, but most times the questions will be given this from 1 hour 20 minutes, 1 hour 45 minutes, or 45 minutes. You need to be able to convert it. If after all your workings you now mess up here, you know the answers will not be correct. So to do this, 1 hour must be converted to seconds, and by converting to minutes first by multiplying by 60, then convert to second by multiplying by 60 again, it will give us 3,600. Then you had plus 20 minutes. The 20 minutes here will be worked separately. That's why it's inside a bracket. And you have 20 multiplied by 60 as well to give, because 20 minutes to second will be multiplied by 60. We have 1,200, and the total answer is 4,800 seconds. So I'll advise you, because this question has been, the topic has been carefully selected based on the WAEC syllabus. I will advise you to study more, expose yourself to more questions, more WAEC questions, especially because that is the exam you want to write, and you need to expose yourself to it so that you will be perfect, and then it will increase your confidence. You will not end up practicing in the exam or. So I wish you all the best, and I want to commend your effort by paying attention to the teachings. Watch out for the second part of this introduction to chemistry, which is on the scientific method. Do not hesitate to ask me questions if you don't understand any aspect. Thank you.